So in this section, we'll see the impact of management policies on the sale forecast. What we see here is sales data. So x-axis is the timeline and y-axis is the volume of sales. And what we see here in these callouts is our management decisions which are impacting the sales. Most of these decisions are related to promotions or inventory sell-off or forward buys, which actually accelerate the sales. So if you see this time series, it actually has no seasonality or trend, but the data is spiky, and these spikes are correlating with as and when the management comes out with some kind of promotion or sales related policy. These policies are too difficult to predict by statistical analysis because this requires business domain knowledge. Now the question here is that if we have a series like this, can we do a reasonable forecast? Especially using exponential series methods, exponential smoothing methods. Let's simulate this data in Python and just have a look. So here we are. So in this, I'm trying to simulate a spiky data set, sales data set. So most of my data is centered around mean 0 and variance 1. I'm generating 90 such points. And then I'm generating some outliers, 10 of them or 10 or 9 of them, which are having mean at 10 and variance of 1. So you can clearly see that these outliers are mean shifted and by quite a margin. And then I'm going to randomly mix these are outliers with the normal data, and then plot it and have a look. So it almost resembles the noisy data that we saw earlier. These spikes are correlating with the management policy of promotions and other stuff. Otherwise, the bulk of the time series is centered around 0, representing the sales, normal sales, and these spikes representing acceleration in sales because of management policies. So now what can we do? So I'll do 3 things here. One, I will take this series as it is and try to make a forecast using Winter-Holt's method. The other is I can treat these outliers in some manner. Firstly, I will try to replace these outliers with their 95% percentile values and see the impact on forecast. And then I'm going to also do something else. I'm going to, any value of the data which is plus minus 2 standard deviation away, I will replace it with the mean of the data set, effectively clipping all these peaks. So let's see how it's done. So starting from an algorithm or a method called Winsorization, which is basically eliminating all the peaks, replacing all the peaks with the 95 percentile and 5 percentile on the bottom side, and try to clip the peaks of the data. Let's see how this data now looks after Winsorization. So there we are. You can see that some amount of clipping has taken place, and so this is how we can treat these outliers. But as you can see that it doesn't have too much of impact. It has just lowered the peaks slightly, but there's no major impact. The next thing that I want to do is that I want to replace these peaks with the mean of the data set. And how do I detect the peaks? Any data point which is 2 standard deviations away from the mean, I'm going to replace that value with the mean value of the data set. So let's see how it looks. So the green dashed line is what the data looks like after all the peaks have been replaced by the mean of the data set. So you can see a very, very marked difference between the time series that is depicted in green line in comparison to what is there in blue and red line. So basically it's a peak eliminator, and I'm just normalizing, I'm just trying to eliminate all these peaks so that a meaningful forecast can be done using exponential smoothing method. So let's treat all these 3 data series and let's see how they perform as far as forecast is concerned. So firstly, when all the outliers are left untreated, so I'm running a exponential fitting Winter-Holt method on this, and I'm trying to make a forecast for 12 periods, and I'm going to generate a forecast of for 10 future steps. So let's see. So this is how the forecast looks like. This is without doing any treatment to the outliers. This is original data series as it is. Now I'm going to do the same thing on the Winsorized data. And as you can predict that since there's not much of a difference between original data and Winsorized data, the results are going to be almost similar. So if there are spikes in the data, the forecasts are also pretty high. This is what is the take here. Let's see now what happens when we take the data set where we have replaced the peaks with the mean of the data set. So we see a very different result here. This time series is almost resembling the original time series. So this is more realistic in comparison to what these two forecasts are. Let's see, let's visualize the result in table form. So I've made a data frame for all these three forecasts. And I would also like to zoom into this and see what are the differences. So there's a small piece of code for that as a separate plot. So here we are. So the first column is when outliers are left untreated. The second is Winsorized data. The third is mean replaced data. And you can see the first and second columns, they closely resemble each other. But the third column, which is mean replaced data, is not matching with the first two columns. And this can also be seen with this plot. And then I've zoomed in into this forecast. And you can clearly see that there are going to be very large errors if we do not treat these peaks properly, especially when we are using exponential smoothing algorithm, Winter-Holt algorithm. The forecast errors between the original untreated series and the mean treated series are very large. Clearly, the exponential smoothing method doesn't work too well if your data is spiky, and the spiky data needs to be treated properly before it can be used for making any kind of meaningful predictions.